you didn't know, this is boiling water. Add the mac and cheese to the boiling water. Cook mac and cheese for 8 minutes, stirring occasionally. Strain the water, leaving the noodles behind. Add the cheese mix. Add 3 tablespoons of milk to the mixture. Mix the cheese, milk, and noodles all together. Add half a tablespoon of butter. Stir in the butter. Here's some background information on colloids, suspensions, and solutions that will help you to understand organic chemistry and solubility.
Hello and welcome to the video on organic chemistry, and in this video we're going to discuss how organic chemistry relates to our mac and cheese product, specifically Kraft's Phineas and Ferb mac and cheese. Alright, so in mac and cheese you'll find that there are proteins. Now what are proteins exactly? Well, I'm glad you asked. A protein is made up of a carboxyl group and an amino group, and what Allison is drawing right now is a carboxyl group, and this just consists of carbon double bonded to an oxygen and single bonded to a hydroxide ion, ion attached to the rest of the compound, and that's simply what the R represents, and that's what it's going to represent throughout the rest of this video. A protein is also made up of an amino group, which is an amine, and now what is an amine? An amine contains one nitrogen ion with a lone pair and at least one hydrogen atom, and that is what Allison is drawing now. So you'll see the lone pair represented by those 2 dots, and she's drawing 2 hydrogens, and this could have 1 hydrogen, or in this case 2, or even 3 hydrogens if you wanted to, and then bonded to the rest of the compound. And what are proteins contained in? Proteins are contained mainly in the cheese and the flour in the macaroni. And now we're going to move on to fats. And what are fats? Well, you might recognize them from your mom. Just kidding. But fats are generally insoluble in water, and if you watched the solubility video, you'll understand a little more about that. Fat molecules are also called triglycerides, and what is in a fat molecule? It combines glycerol with 3 fatty acids. Now, glycerol is simply represented as HOOHOOH, and now that sounds really complex, but as you'll see, Allison is drawing what that looks like, so that makes it a little bit more manageable. So that's simply a hydroxide ion bonded with another hydroxide ion bonded with an OH group, and then that'll just be that'll be somewhere within the compound. And fats are also made up of fatty acids. Now, what is a fatty acid made up of? A fatty acid is made up of an aliphatic compound attached to an acid containing a carboxyl group. Now, you should know what an acid is. It contains hydrogen at the beginning, and then it should have the carboxyl group after that. So the carboxyl group is simply what's circled now. That's the blue compound there. And we talked about that earlier when we were talking about what proteins are made up of. Now, what is an aliphatic compound? An aliphatic compound is simply a non-aromatic carbon compound. And that's just a compound that contains hydrogen and carbon. So there are various types of that, and that's found at the terminal end of the molecule. And fats are mainly found in the cheese in the macaroni. Now, carbohydrates are also found in macaroni, and that just simply takes the form of CmH2ON. So that's pretty self-explanatory. The M represents a constant. That can be any arbitrary constant you would pick, and the N also represents a constant. So for example, you could have C6H2O5 or C4H2O7. So that can be represented by various compounds. And carbohydrates are mainly found in the pasta in the macaroni. So this should give you a basic introduction of what kind of organic compounds you can find in macaroni, and this also shows how chemistry can apply to your daily life. I hope this helped.
Here is a helpful reminder of the different phases and their properties. Phase change diagrams help to show when a substance will change phases. Axes on a phase change diagram are the pressure that the substance is under, and the temperature. And these can be any unit. It does not matter. So right here, anything in this area over here, the substance is in a solid state. Anything in this area, it's in a liquid state, and anything over here, it's in the gas state. In the middle, where the lines intersect, that is the triple point, where all three of the states are at equilibrium. At the end of the line that separates the liquids and gases is the critical point. At the critical point, and at a greater pressure and temperature than the critical point, the liquid and gas stages are indistinguishable. When a solute is added to the substance, the lines on the phase change diagram move down, like so. And this helps to remember boiling point elevation and freezing point depression, because the boiling point temperature is increased and the temperature where the substance freezes is decreased.
Colligative properties are physical properties of solutions that depend on the concentration but do not depend on the identity of the solute in the solution. Some examples of colligative properties are vapor pressure, boiling point elevation, freezing point depression, and osmotic pressure. All of these are related to the amount of solute in the solution.